scientists warn of more powerful solar eruptions hitting Earth. Solar eruptions, also known as solar flares and coronal mass ejections (CMEs), are some of the most energetic events in our solar system. These eruptions occur when the sun's magnetic field undergoes a sudden rearrangement, releasing massive bursts of energy and charged particles into space. While Earth is protected by its magnetic field, these solar storms can have significant impacts on technology, communication systems, and even power grids. Recent scientific studies and expert warnings have highlighted the increasing potential for more powerful solar eruptions to impact Earth in the coming years. Understanding these phenomena and their possible consequences is crucial for mitigating the risks and preparing for their effects. #, the sun's behavior and solar cycles. The sun is not a static body. It experiences an approximately 11-year cycle of activity, known as the solar cycle. During periods of high solar activity, the sun produces more sunspots, solar flares, and CMEs. These phenomena are linked to the sun's complex magnetic field, which undergoes periodic reversals and fluctuations. Solar flares are sudden bursts of intense radiation across the electromagnetic spectrum, while CMEs are massive ejections of solar material and magnetic fields into space. When these events are directed toward Earth, they can interact with the planet's magnetic field, leading to a variety of potential effects. The solar cycle is divided into phases, with the sun moving from a quiet period of minimal solar activity to a more active phase, with frequent solar eruptions. Currently, we are in the rising phase of solar cycle 25, which is expected to peak around 2025. Predictions for this solar maximum suggest that the sun could experience significant activity, including powerful solar flares and CMEs. While solar eruptions are a natural part of the sun's behavior, the intensity and frequency of these events are expected to increase in the coming years, with potential consequences for life on Earth. #, the impact of solar eruptions on Earth. Although Earth is shielded by its magnetosphere, which deflects most of the solar wind and charged particles, intense solar eruptions can still have profound effects. One of the most significant risks posed by solar flares and CMEs is the potential disruption of satellite systems. These eruptions can damage or destroy satellites in orbit by causing electrical surges and damaging sensitive components. Communication, navigation, and weather satellites are especially vulnerable, as they rely on delicate electronics that can be easily fried by the intense radiation from solar flares. In addition to damaging satellites, solar eruptions can interfere with radio communications, particularly in high-latitude regions. The ionosphere, which is a layer of charged particles in Earth's atmosphere, can be disturbed by solar radiation, leading to radio signal degradation or even complete blackouts. This can affect both military and civilian communications, especially in areas near the poles, where the Earth's magnetic field lines converge and solar particles are funneled toward the planet's surface. Another major concern is the potential for solar storms to disrupt power grids. In 1989, a powerful CME caused a massive blackout in Quebec, Canada, when the surge of charged particles induced electrical currents in power lines, damaging transformers and other critical infrastructure. A similar event today, with the increasing reliance on electricity and advanced technology, could cause widespread disruptions to power grids, affecting millions of people and causing long-term economic damage. In a worst-case scenario, a massive solar eruption could damage transformers on a global scale, requiring years to replace and repair the damaged infrastructure. Solar eruptions can also increase the levels of radiation in Earth's atmosphere, which could pose a risk to astronauts in space and high-altitude airline flights. While the Earth's atmosphere provides some protection from this radiation, high-altitude flights, particularly those near the polar regions, can be exposed to higher levels of solar radiation during intense solar events. In the future, with the growing number of commercial spaceflights and human missions to the Moon and Mars, the risk to astronauts becomes a critical concern. Scientists are actively researching ways to shield astronauts from solar radiation during extended missions beyond Earth's protective atmosphere. #, the science behind solar eruptions. Solar flares and CMEs are driven by the sun's magnetic field, which is constantly shifting and evolving. The sun's magnetic field is much stronger than Earth's, and its behavior is responsible for driving solar activity. The sun's outermost layer, the corona, is composed of highly ionized gases that generate the sun's magnetic field. This field is organized into complex structures, including sunspots, which are regions of intense magnetic activity. When the magnetic field lines in these sunspots become twisted and entangled, they can release vast amounts of energy in the form of solar flares and CMEs. Solar flares occur when the magnetic field lines suddenly snap and reconnect, releasing radiation across the electromagnetic spectrum, from radio waves to X-rays and gamma rays. CMEs, on the other hand, occur when large bubbles of plasma and magnetic fields are ejected from the sun's corona and travel outward into space. The effects of solar eruptions on Earth depend on the size and direction of the eruption, as well as the strength of the sun's magnetic field at the time. A direct hit from a large CME can induce geomagnetic storms on Earth, leading to disruptions in power grids, satellite systems, and communication networks. However, if a CME is not directed toward Earth, its effects are minimal. #preparing for solar eruptions. While it is impossible to prevent solar eruptions from occurring, scientists are working to better understand these events and develop strategies to mitigate their impacts. One of the most important steps is improving space weather forecasting. By monitoring solar activity and detecting early signs of solar flares or CMEs, scientists can provide advance warnings to protect vulnerable systems. For example, satellite operators can shut down or reposition spacecraft to minimize damage from solar radiation, and power grid operators can take steps to protect transformers from electrical surges. Additionally, researchers are exploring ways to strengthen infrastructure against solar storms. Power grids, for example, could be designed with more robust transformers that are less susceptible to damage from geomagnetic-induced currents. Similarly, communication systems could be upgraded to be more resistant to solar interference, and airlines could alter flight paths to avoid high radiation zones during intense solar events. Finally, international cooperation will be key in addressing the global nature of the risks posed by solar eruptions. Solar activity does not respect national borders, and a large solar storm could affect countries around the world. Collaborative efforts to share data, research, and technology will be essential in developing a coordinated response to potential solar disruptions. Conclusion. Solar eruptions are powerful natural events that can have significant consequences for modern society. As the sun enters the peak of its 11-year solar cycle, scientists are warning that more powerful solar flares and CMEs could strike Earth in the near future. These events have the potential to disrupt satellite systems, communication networks, power grids, and even human space exploration. While the risks are real, advances in space weather forecasting, infrastructure protection, and international cooperation offer promising solutions to mitigate the impacts of solar eruptions. As we continue to rely on technology in our daily lives, preparing for solar storms is an essential step in safeguarding the systems that keep our modern world connected and functional.